What's going on, you guys? Welcome to another awesome video. Damn, that was cheesy. In this video, I'm going to be showing you how you can use Solidworks and 3D printing to create awesome custom headphones like these. I'm so happy this worked out so well. What you're seeing here is a basic circuit board created by a company called Adafruit. They make custom circuit boards and things that you can run off Arduinos so that you can create awesome projects like this. And then I found a company called Print Plus DIY, which sell these headphone kits. So they give you everything, the wires, the earmuffs, and the speakers to create your own 3D printed headphones. So I thought, what a great opportunity to take two really cool concepts and just mash them together using Solidworks and 3D printing. Let me turn these off before the batteries die. I've seen both projects at two different times and I thought, let me put them together. Print Plus DIY sells these kits that you can buy, and then you can then 3D print your own headphones. They've got a couple of designs on their website already, and you can print in whatever color you want, and they become your own headphones that you build, which is really, really cool. But I had also seen these really cool light up headphones that Adafruit had made, and I thought I could totally put these together into one. So I went to both websites, I got all the equipment I needed. I then downloaded the step files from the Print Plus DIY company because I wanted to use their files and customize their step files, and then add on the covers which house the electronics for the lights. So let's get into how I made these headphones using SolidWorks and the 3D printing and the soldering process. So jumped into SolidWorks. I was going to start designing the little caps that fit over the ends of the Print Plus DIY components. While doing this, I was using a vernier caliper to measure up the rings, the LED rings that I was going to be using, the components I was going to use, and make spaces for them where they're going to fit in. I plan to print this in a multi-material so that the ring is a natural PLA and the rest of it will be a grey PLA. So to do this, obviously I had to keep that ring a separate body throughout the whole design process. Made sure I added all left and right just to keep myself orientated so that I know which side is going to go on which side. I then opened up the step files in SolidWorks and saved them as a part. This is purely so I can bring them into an assembly. I mated them in the correct orientation, and then I used the edit part feature so that I can edit it within the assembly and within the constraints of the little caps that fit over, and I can get the cutaways and the additional material I needed to add in the correct places, and so that it will fit well together. Last thing I needed to edit was the head strap. I added on the little channel to run the wire around the top, but that was a bit of a problem later, and I'll get into that in a minute. These were the first little bits that were needed to be printed. This was the multi-material part here. Because it was only a little bit of clear PLA that was needed, it didn't use much of a purge tower. These are the modified Print Plus DIY parts. And this was the headband. There was a little bit of material added at the ends of the tips. This was added to stop it from warping, because having just the two small points caused a lot of warping, so this piece of material had to be added on. It gets cut off at the end. So using a very sharp blade, I needed to cut off that extra bit of material on that front. Broke away fairly easy and that's thrown away. Use the scalpel to then clean up the edge of the rim. So what happened with this, because I added that material on there, I essentially made it much stronger and it caused it to not actually flex correctly, which means it didn't fit very well. As you can see, it does not flex at all, which is really bad. It's always important to cut away from you to avoid unnecessary harm, like putting a scalpel through your hand, which I've done before. Not fun. So I used a couple of crocodile jumper cables just to kind of roughly assemble the Arduino circuit so I can test it, and then I went to actually solder the bits together. If you've never done any soldering before, I would suggest practicing. Watch a couple of videos online just to see how to correctly do it. I'd never done much soldering before this and it's very easy. Once I got the cables aligned and everything, I used a heat shrink to kind of create my own cable. So the way this works is that you add a bit of heat and it shrink wraps the cables. Because I wasn't using the channeled version of the head strap, I needed to improvise here and I needed to make my own cable. So I measured the cables going around to about where I wanted them to go. I then added a little twist to kind of mark where I wanted the cable to end. Then I just added one after the other another piece of heat shrink tubing and used my lighter to kind of shrink them. And before final assembly, I just ran through the app one more time just to make sure all the features work. Once I was happy with that, I decided to assemble all of the Print Plus DIY components. As you can see, all the electrical components and the earmuffs and the strap come together, and all I needed to do was thread the wires and assemble it. Really simple. Very clever little wires where you don't need to solder anything, you just need to clip them into place. I then fitted on the earmuffs and screwed it in place. Plugged all the cables in. Before I went any further, I just wanted to make sure that it fit and it worked fine, because the previous version obviously it didn't open up properly. I then just used a bit of masking tape to hold the LED caps in place. And then prototyped it to test if it'll fit and if it all works together. So everything was working, so now I was kind of put it together for realsies this time. So I started off with a bit of hot glue on the actual wires just to hold them in place. Hot glue is a good insulator and a good glue for 3D printing, because if you are unsure of it, if you want to change it, it's not a permanent bond. You can kind of twist and crack it apart. Let that all dry. And we'll go off into public just to see how they look out in the real world. So the lights on these headphones are completely controlled through my iPhone. I use the Adafruit app. They've got a controller where I can then pick the colors that I want. Make sure, yep, I can pick the colors I want, the brightness of them, and I can go to these pre-programmed programs they've got. Which are damn cool. And my favorite, the rainbow. So all these colors can be controlled from the phone. You just need to plug in the headphones. It's an iPhone, I need a dongle. Open up your music app. I may have gotten a little carried away there. So this was a fun project. This shows you how easily accessible electronics has become to everyday users. I've never done anything like this before. All I did was have a look at their instructions, followed it, bought the equipment, put it together, and used my knowledge of Solidworks and 3D printing to put a little case around it and house it into these headphones. Well, I would call this version 1. There is a lot of room for improvement, but it's a good start. I now know a bit about programming LEDs and soldering circuit boards, and this is a lot of knowledge that I wish to use in future projects. With companies like Adafruit that are that are coming up with these cool ideas that you can then adapt. They follow a similar philosophy that I do, where in these videos I show you basic ideas for you to then go out into the world and then expand on them, make them bigger, make them something new. I hope you enjoyed what you've seen here. If you know a lot more about programming LEDs, I hope this inspires you to create a whole new project, or maybe you just want to try out something like this. Please leave a comment down below. If you have any questions, please like this video, and we'll see you guys in the next one. Pew, 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 pew.